Okay. Let's go over some algebra. We're about to finish up a unit, and so this is obviously the study guide for Unit 4. We've been learning a lot of things in Unit 4. It talks about functions. We started with, what does a function mean? What does it look like? What scenarios can we use functions in real life? What's an input? What's an output? What's an independent variable, dependent variable? And then it kind of jumped into like um what are all the possible input values? What are all the possible output values for domain and range? Maximum, minimum, piecewise functions, absolute values, right? So now we're here. And let's look at the study guide that you know, um, that'll help us on the test. So the cost for an upcoming field trip is $30 per student. The cost of the field trip C in dollars is a function of the number of students. Again, I say this all the time. Most of us aren't understanding what the question is asking, okay? And you know how to solve it. You just don't know how to approach the problem. So read through the directions carefully and start highlighting or underlining things that are key pieces of information. Field trip is $30 per student. Cost of the field trip and dollars is a function of the number of students. Select all the possible outputs. What does that mean? That is the range, possible outputs for the function defined by C of x is equal to 30x. So when we look at this situation, we know the cost of the field trip is the output, and we know the number of students is the input. Why? Depending on the number of students, right, the cost of the field trip would change because the field trip costs $30 per student. So they're asking us, what are all of the possible outputs here? These are all how much the cost of the field trip, how much the field trip costs. Cost of the field trip, right? And again, depending on how many students went. So logically, just by understanding that the function is 30x, right? Every student is $30. So then the possible output values has to be multiples of 30. They have to be multiples of 30. Multiples of 30, since each student costs $30. So then if one student goes, then it's going to be a $30 field trip. So 20 is not even possible. And this works. Again, if two students go, 30 times 2, that's 60. So 50 is not a possible output. If 3 students go, 30 times 3 is 90. If 4 students go, 30 times 4 is 120. So 100 is not possible. So the only two possible values here are 30 and 90. How can you show your work? Like algebraically, we know this is the output. This is the output. And this is the input, right? Input and then output. So we're basically saying, is 20 a possible output value? What if you set the 30x equal to 20? And you solve for x. If you divide both sides by 30, what do you get? X equals, that's 1 over 3, which is 0.33, 2 over 3. So that's like 0.6666666. So again, it goes on forever, right? It's not possible. X stands for number of students. It's not possible to have like 0.66666 students. So this doesn't work. 20 doesn't work. Okay, so that's another way to solve it. But those are your answers there. Okay, B and D. B and D. Okay, let's keep going. A small bus charges $3.50 per person for a ride from the train station to a concert. The bus will run if at least 3 people take it, and it cannot fit more than 10 people. The function B So hold up. $3.50 per person, at least 3 people, and then it cannot fit more than 10 people. The function b gives the amount of money that the bus operator earns when n people ride the bus. So amount of money, output. N people, inputs. Identify all numbers that make sense as inputs and outputs for this function. So what's the domain here? Or possible inputs, right? And you could just list it. It says at least 3 people and at most 10 people. So the domain here is 3, 4, 5, 6, 7, 8, 9, and 10, right? Only for, and like the amount of people from 3 to 10. And you can't say like this doesn't work, okay? Because this includes all like 3.5, 3.2, 3.7, 3.8. You can't have point something per people, right? So that is not going to work. And then all the possible range, the range is all possible outputs. Is the multiple, depending on how many people there are, you multiply that by 350, and that's going to be the range. So 3 times 350, that's 1050. 4 times 350, that's 14. 5 times 350, that's 1750. 6 times 350, that's 21. 7 times 350, that's 2450. 8 times 350, that's 20. Is that 28? Hold up. Yeah, 28. 9 times 350, that's 3150. And then 10 times 350, that's 35. Right? So now those are all the possible output values. Right here it says sketch a graph of B. I'm going to sketch that up there. So then at 3, it's about 1050. So I'm going to just plot the point right there. At 4, about 14. At 5, 1750. At 6, 21. 7 is 450. 8 is 28. 9 is 3150, and 10 is 35. Now, am I going to connect the dots here? No, right? Because as soon as you connect the dots, that includes every number between the points, and that's not the case, okay? So you're just going to leave it like that. You're going to leave it like that. Okay, next question. A child tosses a baseball up into the air. On its way down, it gets caught in a tree for several seconds before falling back down to the ground. Select the best description of the range of this function. What's the best description of the range of this function? Okay. Range includes all numbers from 5 to 12.5. Remember, we said range was the y. Look at the y-axis, and then look at the x-axis for domain. X-axis, y-axis. Okay, so this graph, does it cover only points from 5 to 12.5? Is that true? 5 to 12.5, that's the only part of where the graph covers? No, absolutely not. It covers down here as well, so that's not true. That's not true. What about range includes all integers between 0 and 12.5? Integers means only whole numbers, right? Integers means only whole numbers. That's not true. It covers every number, so it's not going to be B. All numbers from 0 to 8.5? 0 to 8.5? 8.5 is like right here. That's not, no, that's not true. So it's got to be D. All numbers from 0 to 12.5. Right? Because it covers all numbers from 0 to 12.5. It goes up, down, right? Okay. Describe the domain of this function. What about the domain? Domain is the x-axis. So I'm kind of looking at it from here all the way to here. Okay, so the domain would be something like all numbers from 0 to, let's just assume that that's like 8.5, right? 8.5. That's it. To raise funds for a trip, members of a high school math club are holding a game night in the gym. They sell tickets $5 per person, and the gym holds a maximum of 250 people. The amount of money raised is a function, again, amount of money raised, how much, what is that, the output or input? Right? That's output, is a function of the number of tickets sold, input. So depending on how many tickets sold, that's going to change the output. Which statement best accurately describes the domain? All possible inputs of the function, right? So again, input is the number of tickets sold. How many people can they sell tickets to? A maximum of 250. Maximum of 250. And the domain, remember, it's people. We're talking about people. So you can't have 3.5 tickets. You gotta have 1, 2, 3. So it's all positive integers, right? Integers is whole numbers. It's another way of saying whole numbers. So all positive integers. Is that true? Can we get more than 250? No. So that's not true, right? But I'm just trying to tell you what integers mean. All integers could also include negative numbers. Also includes negative numbers. So it's not all integers, right? It's not all integers. All numbers less than 250? No, it's not every number. It's all positive integers less than or equal to 250, okay? The graph shows h. The graph of h shows the height in meters of a rocket t seconds after it was launched. Find h of 0. H of 0. 0 is the input. So then at 0, they're asking you what's the output. What's the output? What is the output at 0? What does this value represent? H of 0 equals 15. That represents, what does that 15 represent? 15 is on the y-axis, the height. The height of the rocket at 0 seconds, right at the beginning. Okay. Describe the domain of this function. Domain, x-axis. Looking at the x-axis, what are all the possible values? Possible input values of the function. It goes from 0 all the way to, I'm going to say like 4.7, right? 4.7. So describe the domain of this function. All numbers from 0 to 4.7 around, estimate. Okay, estimate. Describe the range, y-axis, and then also possible output values. Output values, okay? So y-axis is this part right here. So does it hit 0? Absolutely. What's the highest it goes to? It looks like about, let's just assume that's 35, okay? 35. So y-axis, all numbers from 0 to 35, okay? Solve h of x equals 0. So the output is 0. What does this value represent? So when is the output 0? The output is 0 at about 4.7. So h of x equals 0 when x equals 4.7. This represents the time of the rocket reaching the ground. Okay. A parking garage charges $5 for the first 2 hours, then $10 for up to 4 hours, and then $12 the entire day. So let G be the cost of parking for T hours. Complete the table. So at 0 hours, if you didn't park at the parking structure at all, that's $0. At half an hour, so 30 minutes, it's going to charge you $5, $5. At 1 hour, it charges you $5. At 3 hours, so after the first 2 hours, it's not $5 anymore. It's going to be $10. And then at 4 hours, so it says $10 for up to 4 hours, right? And then anything past that would be the $12. So at 4, that's still $10. And then at 6 is past that, so that's 12. So I completed the table. Let's sketch a graph from 0 to 12, right? From 0 to 12. So again, at 0, if you didn't park, or at 0, it's still $0. If you leave within the minute, I guess. And then for the first 2 hours, it's going to be $5. So it's going to be $5 from 0 to 2, just like that. Okay. Just like that. And then as soon as 2 hours passes, you're going to jump all the way to $10 from 2 to 4 hours, right? From 2 to 4 hours. So it's going to look like this. And then it's going to be $12 for the entire day after 4 hours. So it's going to look all the way. It's going to go all the way like that. Okay. Write the piecewise function that goes with the situation. So how will we write this down? Right. So it's saying the function is G of, I don't know, should we do T for time? Yeah, G of T. So G of T is equal to, we're going to say 0 if T is equal to 0. Okay, if T is equal to 0, that's $0. That's what this point is. And then after that, we're going to say the output is what? $5, right? It's going to equal 5 if what? T is greater than, so 0 is less than T, and then it's greater than or equal to what? Up to 2 hours, right? So T is greater than or equal to 2, or less than or equal to 2, I'm sorry. And then from 2, it jumps all the way up to 10, right? 2 to 4. So 10 if 2 is less than T is less than or equal to 4. Because 2 is right here. The output is $10. So we're saying the ticket costs $10 as soon as it passes 2. And all the way up until 4. And then the last one was 12. So it's going to cost $12 if you start from 4 hours, anything past 4 hours until 12, right? For less than T is greater than or less than or equal to 12. That's it. Whoa. Lots of questions. Okay. Number 7, use the graph of function G to answer these questions. What are the values of G of 1, G of negative 12, and G of 15? G of 1 on the x-axis is about here, right? I'm assuming this line is 1. But then this is the open circle, so we're not counting that. It's got to be at the closed circle. So the output at 1, that's going to be 4. So G of 1 is equal to 4. G of negative 12. Negative 12 is down here. And so the output at negative 12, let's assume that's like right in the middle. So we're going to say negative 10. And then G of 15. 15 is, I'm going to assume like right here. Whoa, where's 15? 12. These are by 4s. So that's 16. So 15 is going to be nothing, right? Undefined. There's no point at 15. Undefined. Okay, undefined. There's no point. There's an open circle at 15, right? But there's no actual circle at 15. So it's going to be undefined. It wouldn't even be 8. For what x values is g of x equal to -6? So when's the output -6? Right here. What are the input values, right? What are the input values for when x is -6? So g of x equals, sorry, y is -6. G of x equal to -6 when the input goes from -8 is less than or equal to, right? Because the -8 is included, and then x, and then again, open circle means less than. I'm going to assume